we go. We're going to do graphs of functions. We're going to be talking about their key features. Their key features are domain and range, increasing and decreasing, as well as relative minimum and maximum values, and last but not least, your axis of symmetry. Domain and range of a function. What is the domain of this graph? We can see that this is part of a parabola. And it's going, if you look at it on the left side, you can see you have a solid colored dot that's going to be inclusive at the point -1, -5, and it goes to the other point, which is open for 0. So your domain is going to be the x values of those 2 points. So it's going to be, notice the bracket for -1 because it's included, comma, 4 parentheses because the 4 is not included. Okay, now what is the range of this graph? Okay, and the range, again, you're looking at the same 2 points, -1, -5, and 4 and 0. However, for the range, you have to take into account going from the minimum to the maximum. So our range here and everything is going to be included. There's no open points for the range. So we're going to go from -5 to 4. Notice the brackets on either side. Sometimes what they want you to do with a graph is they will give you some x values. So the f of -1 really means what is the value at -1. So if you go to -1 on the graph and you go down, we would go down till the point -1, -5. So the value is -5. Then the next one is f of 2. So if you come to x equals 2 and you go up, you'll see that your value is 4. So they're telling you what the x values are, -1, and they want the y value, -5. The x value is 2, and then they want the y value of 4. Okay, we're going to look at domain and range function using more of an algebraic approach, and then we're going to check it by looking at the graph. Okay, they want us to find the square root of x minus 4. Okay, so the expression under the radical cannot be negative because of the square root. So if we set x minus 4 has to be greater than or equal to 0, and we go ahead and solve that, we know x has to be greater than or equal to 4. Now 4 will be included, but then it's just going to go to infinity. Since the domain is never negative, the range is also going to never be negative as well. And we can express that as y greater than or equal to 0 or bracket 0 to infinity, and that would be your range. Let's take a look at what the graph looks like, and there it is. So notice that the graph starts at 4, 0, and then just goes on to infinity. Increasing and decreasing functions. First of all, the graph must be read from left to right. You must always read your graphs from left to right. If the line is going up, you're increasing, and if the line's going down, you're decreasing. The more you know about the graph of any function, the more you know about the function itself. So consider the graph on the next slide. This graph has a decreasing area, a constant, and an increasing. Notice the x values are going from -2 to 4. So when we talk about increasing and decreasing, we're always looking at the x values, okay? So it's falling or decreasing from x equals -2 to x equals 0. We have constant line from x equals 0 to x equals 2, and then it's rising from x equals 2 to x equals 4, or increasing from that interval. Sometimes uh, find the open intervals on which the function is increasing, decreasing, or constant. This is a cubic function, and so it's actually increasing over the entire line. There's never a constant area. It's just an increasing from left to right. Here we have another function. It too is a cubic function. Notice that we are increasing during 2 intervals from negative infinity to -1. Again, we're only looking at the x values. And then x equals 1 to infinity, you're increasing again. And then you're decreasing between -1 and 1. Now here we have a piecewise function, and we have three different things happening. And again, we're just going to look at the x values. So we're increasing from -infinity to 0, or the y-axis. We have a constant from 0 to 2, and then we have a decreasing from 2 to infinity. Now please notice that the constant has the 0 and the 2 is in brackets for that part. But for the other parts, everything's in parentheses, okay? So you have to determine where your brackets and parentheses are going to be. Relative minimum and maximum values, the point at which a function changes its increasing, decreasing, or constant behavior, are helpful in determining the relative maximum or relative minimum values of a function. Notice that when you look at the what I call the mathese, the math language here, notice that we are looking at the same interval, okay? However, if it's a minimum, notice that this is less than or equal to. If it's a maximum, it's greater than or equal to. That's the only difference between these. All right, and we'll find exact points later, but you can see that you can have a number of, and they're called relative maximum or relative minimum. So here we're using probably a TI 84, and you can actually do this with the calculator, which I'll have to show you guys later. But we can find relative minimums and we can find relative maximums. You're going to want to use the calculator or Desmos for that. All right, what is an axis of symmetry? The axis of symmetry is a line through a shape so that each side is a mirror image. Okay, so the first one's a parabola. You guys needed to find the axis of the symmetry last year with parabolas. You'll notice you have x equals 3 in this case, and that's your axis of symmetry. Here, the other graph is a cosine graph, and x equals 0, in other words, the y-axis, mirror image. And then the third graph has no axis of symmetry. All right, let's take a look at our example here. It says to find the key features of the f function graphed here. Is the graph increasing or decreasing from x equals -2 to x equals 0? So we need to look from -2 to x equals 0 over this interval here, okay? And we can see that it should say that it is decreasing. Then is the graph increasing or decreasing between 2 and 3? And so that would be over here on this side. And so that is increasing. Okay. Our x-intercept, because it's a parabola and the way it's crossing the x-axis, we have 2, -1 and 2. We have a y-intercept, y equals -2. Now they tell us to evaluate at f equal 1. And so when we come down here, we can see that y is equal to -2. That should be -2. Do we have a maximum? There is none. We do have a minimum. It's 0.5, and then, so it's right down here, 0.5, and then -2.25. The domain for a parabola is always -infinity to infinity. However, our range, notice that we're using our minimum for our range. And actually, that should be a bracket because it is included. Okay, and the axis of symmetry, again, is taken from the minimum. All righty, let's look at our next one. Our next one is a piecewise function. Where is the function decreasing? And again, you have to look at the decreasing, we can see we've got some decreasing coming down here, and then it's decreasing here. Okay. We're going to give the brackets, it's coming from, we have to use the x values, so it's coming from negative infinity all the way over to -2, okay? And then it jumps in x value, and we go from -1 to infinity, because again, you're looking at the x values. Our x-intercept, we have none. We do have a y-intercept, it's -3. Yes, we do have a maximum. This is a maximum. And then we have a minimum, which is right here at -2, 1. It says, what is the h at -1? It's not the open circle, it's going to be the closed circle. So that's 2. The domain for this is from negative infinity to infinity because we have a closed circle here. Even though this is open, there's still a value at -1x. The range, however, does jump. We're coming in the range from infinity all the way down to the lowest point here at 1, unioned with -1, notice that's parentheses, to negative infinity. Do we have an axis of symmetry? No, we don't. So when they're talking about key features here, these are the types of things they ask you for: increasing, decreasing, domain range, x-intercept, y-intercept, maximum, minimums, and then they may ask you for certain points off your graph as well as axis of symmetry. And that's all, folks.